Hello students. So this is question number 1314 of paper 2 physics 2021 JEE Advanced. So it's an interesting paragraph. All the information that we need to solve has been given in the paragraph itself. So the question says that there is a small dipole magnetic moment M and it is traveling towards a superconducting loop of radius A, and the question tells us that a dipole magnetic moment produces this much magnetic field at a distant point on its axis, and it also tells us the force of interaction between two magnetic dipole moments separated by a distance r and which are aligned along the same line. Okay, and based on this we have to answer two questions. Okay, so let's see the first one of them. So the first one says that when a dipole is placed at a distance r from the center of the loop. Okay, so there was a loop here and from the center there was a distance r and a dipole magnetic moment was here. So this would produce magnetic field here, which would be given by mu naught, let me go back and check, mu naught m by 2 pi r. So mu naught m by 2 pi r cube. So this would be the magnetic field. Now if I multiply it with pi a square, of course we cannot simply multiply with pi a square, but if it's not area, then it would be a factor of area, some factor of area. So to keep things simple, let's consider a as very small and let's simply multiply it with area. So this is the flux passing through this loop, and the current in this loop will develop in a manner so as to make sure that the amount of the flux doesn't change. So if the self-inductance of the loop is L, which has to be a constant value depending upon the dimension of the loop, so I can say that Li must be equal to the flux, which is mu naught m pi a square by 2 pi r cube. Now the most important aspect to see here is that this current is proportional to m by r cube, because this is what we have to investigate, the dependence on m and the dependence on r. So m by r cube, A option looks to be the correct one here. Now, associated with this question is another question. The work done in bringing a dipole from infinity to a distance r from the center of the loop is given by. So, this is the loop from the center. There is a point P at a distance r, and we are bringing a dipole moment from infinity. Okay, and we have to calculate the amount of work done. So in the previous question, what we calculated was that there will be a current developed in the loop, and this current will be proportional to m by r cube. Now, if there is a current, then there would be a magnetic moment of the loop itself. Let me call it as m prime, and that would be given by I into pi a square. Okay, so there would be a magnetic moment of the loop itself, and going by the expression of force, the one that was given to us in the paragraph here, K m1 m2 by r cube, we should write K into m by r cube. Okay, of course there would be other constants also like pi a square, but we can ignore that because anyways we are looking at proportionality only. Okay, so K m1 m2 divided by r raised to power 4. So basically this force is proportional to product of mass m square and divided by r raised to power 7. Okay, now to calculate the work done, we need to integrate f dr from infinity to r. So that will leave us with proportionality of m square divided by r raised to power 6. Okay, so that means C option should be the correct option here. So it's a good question. The trick here was to understand that in this expression km1 m2 by r cube, one of the m could be dependent on r itself. This is a point that may be missed by many of the students, and if that is the case, then many of the students may not be able to get the question number 14th correct. Question 13 is easy, but getting 14th one correct is a bit tricky. Alright guys, I hope you enjoyed the solution. I'll bring solution to the next question in my next video. All the best and take care.